So let us continue our discussion. We are discussing about context-free languages. We have completed CYK algorithm in the last class. In the last class, we have completed CYK algorithm, and now we will go with GNF, Greback normal form. Okay, we will go with Greback normal form, and this is the Telegram channel that I have. If you have any questions, doubts, queries, or any updates, I will be sharing on Telegram channel. Please join this Telegram channel. Okay. And now let's talk about Alexander Bruce, sciences accidental hero. Background: born in 17th century, Scottish businessman turned scientific collaborator. Lifelong outsider, no formal training, no recognition from academic elites. He helped improve early pendulum clocks to fix navigation problems. He improved timekeeping from the sidelines. If you could do it without credentials, you can succeed from nowhere. Okay. So if you could do it without any formal education, with this kind of support you have, you should be able to achieve even more. Okay. Okay. So let us see GNF. Greback normal form. Okay. So if all productions are of form if all productions are of form A derives A alpha where alpha belong to V star, then it is called GNF. Then it is called GNF. Which means, for example, all the production should be like this. A derives A, B, C, D, E like this, or the production can be like this. Right? What is the advantage? Advantage of GNF. What is the advantage of GNF? The advantage of GNF is that the number of steps required to generate a string of length W is W. Okay. For example, if S derives A, B, C, then B derives small b, then C derives small c. Now if you can see this, in order to generate a three-length string, how many steps we had? We had 1 step, 2 steps, and 3 steps. In order to generate a three-length string, we have 3 steps. In order to generate three-length string, we have 3 steps. Okay, we have 3 steps. In order to generate three-length string, we have 3 steps, right? So this is the advantage of GNF. And what is the main advantage of GNF? So GNF is used to convert context-free grammar into push-down automata, right? Now we can take any context-free grammar and we can convert it into GNF, and we can take any G and F and we can convert into push down automata. There is an algorithm for this, there is an algorithm for this. Therefore, this problem of converting context free grammar to push down automata, this is decidable. There is an algorithm for that. This is decidable. This is decidable. This is decidable. This is decidable. Okay. Now let's see one example where how to convert CFG to PDA. Okay. Conversion of context free grammar to push down automata. Conversion of context free grammar to push down automata. Okay. Rule number one is push the start symbol. Rule number one is push the start symbol A onto the stack. Push the start symbol A onto the stack, which means if you are in state Q0 without seeing anything, Z0 is on top of the stack. You just push, you go to Q1 and you push start symbol. Let us say start symbol is Z0. Without seeing anything, you push Z0. Okay. And step number two is push RHS of A. Push RHS of A as follows. Push RHS of A as follows. Delta of Q1 comma A comma capital A. Delta of Q1 comma A comma capital A is equal to Q1 comma alpha if A derives A alpha is in G. If A derives A alpha is in G, right? Otherwise, convert Q1 comma B comma A equal to Q1 comma B comma A equal to Q1 comma beta if A derives B beta is in grammar G. Okay. And the third step is add final state. Add final state with delta of Q1 comma epsilon comma Z0 equal to QF comma you can write Z0 or epsilon, anything is fine. QF comma Z0 or epsilon, anything is fine. Okay. I really think that you didn't understand anything here. You didn't understand anything in the algorithm, right? This is the algorithm, but you didn't understand anything. But I will take a problem and make it easy for you. Okay. Let's see a problem on this. Okay. Now let us see how to convert a grammar into GNF. Okay. So let us say a grammar is given like this. S derives A, S, B or AB. How do you convert this grammar into GNF? Right. So S derives A, S, capital B or A, this is small b or AB, and then B derives small b. B derives small b. This is how you convert any grammar into GNF. This is how you convert any grammar into GNF, right? Now let us see how to convert this into pushdown automata. Pushdown automata. Initially, without seeing anything, let Z0 be on top of the stack. Without seeing anything, you just push yes, yes Z0 initial state. Okay? And you go to the state Q0. From Q0, you go to the state Q1, and you stay in Q1, okay, and do all the productions, right, like this. If input is a, if top of the stack is yes, replace s by sb, Similarly, if input is a, top of the stack is yes, replace it with b, right? Similarly, if input is b, top of the stack is capital B, then it is b followed by epsilon, right? Replace b by epsilon, replace capital B by epsilon, and finally, 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 if input is epsilon, top of the stack is Z0, leave it as Z0 or make it epsilon and you accept it. QF, right? 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 Let us see one more grammar. With one more grammar, I'll be able to explain you better. Okay? Let us say the grammar is S derives A, A derives AS or BS or A. A derives AS or BS or A. A derives AS or BS or A. Okay? So this is in GNF. This grammar is in GNF, right? Now let us try to convert it to a pushdown automata. How are you going to convert it? Initially, you will be in state Q0, right? Without seeing anything, without seeing anything, if without seeing anything, initially Q0 is in the initial state without seeing anything. If Z0 is on top of the stack, just push yes, and you go to next state Q1. Stay in Q1 and do all these productions. Okay. So if the input is A, and top of the stack is yes, replace S by AA, right? Similarly, if input is small a, top of the stack is capital A. If input is small a, top of the stack is capital A, replace it by S. If input is small b, and top of the stack is yes. If input is small b and top of the stack is a, replace it with yes, right? Similarly, here also there is a epsilon, right? If input is a, top of the stack is capital A, replace it with epsilon, all the productions are done. Finally, if you see epsilon in the input, which means if the input is over and Z0 is on top of the stack, leave it as Z0 only and you accept it. Okay? So this is all about GNF. So what is the main thing about GNF? What is the important thing about GNF? GNF, if you have to generate a string of length W, the length of the derivation will be length W. Okay? and GNF is used to convert context-free grammar into pushed-on automata. And then we have seen two examples. This is the algorithm. You might not be able to understand it, but then with examples, I think I made it clear. Okay? Okay? Now let us see context-free grammars. Now let us see. So let's see context-free grammars now. Okay? Let's see context-free grammars. Let's see context-free grammars. Before going into context-free grammars, let us see a story. Okay? Let us see a story, inspirational story. Bethany Hamilton, the surfer who rewrote her limits. Background: she is a teenage surfer from Hawaii, talented and fearless. She was attacked by a tiger shark at the age of 13, lost her left arm in the ocean she loved, returned to competitive surfing within a week. Within weeks, she came back to competitive surfing and went on to become a pro and cultural icon. She didn't let the sea own her story, she rewrote it. If she could ride waves with one arm, you can ride tough you can ride through your syllabus with one schedule. We can ride through your syllabus through one schedule. एक छोटी बच्ची है 13 years की, lost her hand, left hand पूरा टाइगर शार्क ने ले लिया है, फिर भी she went on to the सर्फिंग अगेन विद इन वीक्स. ठीक है, क्या हीरो है भाई, क्या हीरो है भाई. ये लोग है असली हीरोज, ये लोग है असली हीरोज. ठीक है, तो नाउ लेट अस सी कॉन्टेक्स्ट फ्री ग्रामर्स. ओके, नाउ लेट अस सी कॉन्टेक्स्ट फ्री ग्रामर्स. तो L इक्वल टू a power n b power n such that n is greater than or equal to 0. L equal to a power n b power n such that n is greater than or equal to 0. What is the context free grammar for that? It is very simple, right? S derives a, s, b or epsilon. S derives a, s, b or epsilon. You can generate any number of a's and b's. S can directly generate epsilon, or S can generate a, s, b or epsilon, or S can generate a, s, b or a, s, b or epsilon. It can generate any number of a power n, b power n such that n is greater than or equal to 0. It can generate any number of a power n, b power n such that n is greater than or equal to 0. N is greater than or equal to 0. Okay? Now let's draw for this. L equal to a power n, b power m, c power n, d power n such that n comma m greater than or equal to 0, right? First you generate a power m. This is a power m. First you generate a power m, b power m, and then generate c power n, d power n, and then put them together, right? First you generate a power n, b power n. A derives a, b or epsilon. Then you generate c power n, d power n. B derives c, b, d or epsilon. Then you put both of them side by side. S derives ab. Then you put both of them side by side. S derives ab. S derives ab. Right? Simple, right? Simple, right? Now if I ask you L a power n, b power n such that n is greater than or equal to 1. The minimal string is AB. N is greater than or equal to 1 means the minimal string is AB, right? How are you going to do this? S derives A, S, B. You have done it already. In place of S, instead of putting epsilon, you put AB. So the minimum string generated will be AB. Always the minimum string generated will be AB. And if you want more ABs, you will get ASB, AB, or S derives ASB, S derives ASB or AB. S derives ASB, ASB or AB, right? N is greater than or equal to 1. N is greater than or equal to 1. If I ask you this, a power n, b power n such that n is greater than or equal to 2. If I ask you this, how are you going to generate it? You are going to generate it as S derives ASB. And what is the minimal string here? The minimal string here is AABB. The minimal string here is AABB. BB. ठीक है. Now if I give you a grammar and ask you what does this grammar represent, let us say a power n b power 2n such that n is greater than or equal to 0. How are you going to generate this? S derives ASBB or epsilon. S derives ASBB or epsilon. S derives ASBB or epsilon. Right? If I ask you what is the language generated by this? If I ask you what is the language generated by this grammar, S derives ASB or ABB. S derives ASB or ABB. What is the language generated by this grammar? Okay. So we know that S will derive by using this production. S will derive A power n, S B power n. Right. Now S will derive ABB. A power n, A B B B power n. Now what will this become? A power n plus 1, B power n plus 2. A power n plus 1 and B power n plus 2. A power n plus 1 and B power n plus 2. A power n plus 1 and B power n plus 2. A power n plus 1 and B power n plus 2. Okay. Now if I give you this grammar, S derives ASBB or S derives ASBB or AAB. What is the language generated? We know that S will derive, if I go only by this production, S will derive A power n, S B power 2n. Right? Now in order to stop S, you have to use this production AAB. Therefore it is A power n, AAB B power 2n. So it is going to be A power n plus 2 B power 2n plus 1. A power n plus 2 B power 2n plus 1. A power n plus 2 B power 2n plus 1. A power n plus 2 B power 2n plus 1. A power n plus 2 B power 2n plus 1. Okay. So we will see more examples. Let's see one more problem. A power 2n B power n such that n is greater than or equal to 0. Okay. So A should be double the number of B's. So how are you going to write it? A should be, for every 2 A's, we are going to generate 1 B or epsilon. For every 2 A's, we are going to generate 1 B or epsilon, right? So you can do any such model. You can do A power 2n, B power 3m, or you can do A power n, B power 10n, or you can do A power 100n, B power 10n. Anything you can do, right? Anything you can do. All these are context-free languages only, because we are able to give context-free grammar. Okay. Now let's try to do this. A power n, B power 2n plus 3. A power n, B power 2n plus 3. Right? So how are you going to write it? You are going to rewrite it like this. A power n, B power 3, B power 2n. Therefore, you generate A power n, B power 2n and you stop with 3 B's, right? Therefore, you generate A power n, B power 2n and you stop with 3 B's, right? And you stop with 3 B's. So, S derives A, S, B, B, A, S, B, B. So, A power n, B power 2n is generated. A power n, B power 2n is generated, or B cube. S derives B cube, right? You are going to stop S with B cube. Okay. Now if I want to do something like this, A power n, B power 3n plus 4. A power n, B power 3n plus 4. I can rewrite it as a power n, b power 4, b power 3n, right? Now you generate a power n, b power 3n and you stop it with b power 4. Okay? So S derives S derives A, S, B, 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 or B, 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 A, S, B, 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 or B, 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 B. ठीक है, ठीक है, ठीक है. And then A power 3n plus 4 and B power n such that n is greater than or equal to 0. A power 3n plus 4 and B power A power n, sorry, A power 3n plus 2. Let me rewrite it again. I have done something wrong. A power n, B power 3n plus 4 such that n is greater than or equal to 0. N is greater than or equal to 0. What are you going to write? You are going to write it as A power n, B power 4, B power 3n. A power n, B power 4, B power 3n. A power n, B power 4, B power 3n. A power n, B power 4, A power B power 3n. Right, right, right. So first you generate A power n, B power 3n, and in between you stop with B4 B's, right? So S derives A, S, B, 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 and then you are going to stop with 4 B's, B, 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 right? Right, right, right. Now if you want to have A power 3n plus 2, B power n such that n is greater than or equal to 0, how are you going to write it? You are going to write it as A power 3n A square B power n such that n is greater than or equal to 0. Minimal string is A, right? So first you generate 3 A's and 1 B. S derives A, S, B, S, B. S derives A, S, B. S derives A, S, B. S, B. S, B. Or if you want to stop it, you are going to stop it with A. You are going to stop it with A. Right? Right? Now let us say A power 2n B power 3n such that n is greater than or equal to 0. A power 2n B power 3n such that n is greater than or equal to 0. A power 2n B power 3n such that n is greater than or equal to 0. Okay? So what is it? S derives A, S, B, 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 or epsilon. S derives A, S, B, 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 or epsilon. ठीक है. Now A power 2n plus 3, B power 3n plus 2 such that n is greater than or equal to 0. Such that n is greater than or equal to 0. Right, right, right. How are you going to write it? How are you going to write it? You are going to write it like this. A power 2n followed by A, B followed by B power 3n, right? So you are going to generate 2 A's and 3 B's, right? So S derives A, S, B, B, or A, B, B, A, B, B, A, B, B, A, B, B. ठीक है, ठीक है. We'll solve more problems. Let's see some more examples. Let's see some more examples. A power m, B power n such that m is greater than or equal to n. A power n, B power m such that m is greater than or equal to n, comma m comma n greater than or equal to 0, right? So m has to be greater than or equal to n, right? So you can rewrite it like this. A's have to be greater, right? A's have to be greater than B's. First you generate equal number of A's and B's. First you generate equal number of A's and B's and you put a star here. Then what happens? Number of A's will be greater than or equal to number of B's. Number of A's will be greater than or equal to number of B's, right? So first you generate equal number of A's and B's. A, B, or AB, or epsilon. Equal number of A's and B's. Right. And then you put A star before it. B derives A, B, or epsilon. 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 This is going to generate A star, right? This is going to generate A star. Now you put A star followed by A power n, B power n. A star followed by A power n, B power n. Now you put A star followed by A power n, B power n. A star followed by A power n, B power n. That's it, simple. A star followed by A power n, B power n. Simple, right? Simple. Now, if I say A power m, B power n such that m is strictly greater than n. M is strictly greater than n, which means these two will never be equal. A's will strictly be greater, right? M comma n greater than or equal to 0. M comma n greater than or equal to 0, right? So A is strictly greater than B. So A is strictly greater than B. Right. So you can write it as A plus A power n, B power n. A plus A power n, B power n, right? So number of A's will be strictly greater than number of B's. Number of A's will be strictly greater than number of B's. Number of A's will be strictly greater than number of B's. Number of A's will be strictly greater than number of B's. First you generate A power n, B power n. A derives A, B, or epsilon. This is generating A power n, B power n. Then you generate B plus A plus. Then you generate A plus. This will generate A plus. This will generate A plus. Now you put A plus before A power n, B power n. A plus before A power n, B power n. A plus before A power n, B power n. Right. Now let us say A power m, B power n such that m is less than or equal to n, which means number of B's are greater than number of A's, right? Number of B's are greater than number of A's. How can I write it? I can write it as A power m, B power n, B star. A power n, 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 B power n, A power m, B power n, B star. A power m, B power n, B star. ठीक है ठीक है ठीक है ठीक है ठीक है. How are you going to generate this? Sorry, this has to be A power n, B power n. A power n, B power n, equal number of A's and B's followed by any number of B's, right? So that number of B's will be greater than or equal to number of B's will be greater than or equal to number of A's, right? First you generate this. How are you going to generate this? A derives A, B, or AB. A derives A, B, or AB. A derives A, B, or AB. Now you generate B star. What is B star? B derives B, or epsilon. B derives B, or epsilon. B derives B, or epsilon. B, or epsilon, right? Now you put them together. S derives A power n, B power n is this one, right? So here if you assume m comma n greater than or equal to 0, you can put epsilon here. You can put epsilon here. ठीक है. Now you put a power n b power n followed by b star, right? Now if I write something like this, a power m b power n such that m is less than n, a power n b power n m is less than n, m comma n greater than or equal to 0, m comma n greater than or equal to 0, m comma n greater than or equal to 0. M comma n greater than or equal to 0. M comma n greater than or equal to 0. M comma n greater than or equal to 0. Right. So A's have to be less than B's. How are you going to write it? A power n, B power n. A's have to be less than B's. A power n, B power n, B plus, right? First you generate A power n, B power n. First you generate A power n, B power n, right? How are you going to generate it? S derives, let us say A. A derives A, B, B or epsilon. This will generate A power n, B power n. Then you generate B plus. How are you going to generate B plus? B plus is going to be generated by BB followed by BB followed by a B. BB followed by a B. B plus, right? Now S derives AB. 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 Right? Now A power n, B power n is generated, and after that B plus is generated. Okay? We will see more problems. Let's see one more problem. A power m, B power n such that m is not equal to n. A power n, B power n such that m is not equal to n. Matlab, what should you get here? M should be less than n or m should be greater than n. M should be less than n or m should be greater than n, right? So how are you going to write it? It is going to be either a plus a power n, B power n, which means a's are greater, or a power n, B power n, B plus, a power n, B power n, B plus, right? So anyway, in both the cases, you have to generate a power n, B power n. Let's generate that. S derives a, B or epsilon. Let's assume m comma n greater than or equal to 0. Okay? Let's assume m comma n greater than or equal to 0. So S derives a, B or epsilon. Right? This will generate a power n, B power n. Now you generate a star. B derives a plus. B derives a, B or a, and C derives BB. C derives BC or B. C derives BC or B. C derives BC or B. BC or B, right? Now what will happen? S derives A plus followed by A power n, B power n. ठीक है? S derives A plus followed by A power n, B power n. Or S derives A power n, B power n followed by A power n, B power n followed by C. BA or C. BA or C. BA or C. BA or C. ठीक है? We will see more examples. Let's now see an interesting question. Okay. Let's now see an interesting question. This is interesting. What is the language? What is the language generated by the following grammar? S derives A S1 or S1b, S1 derives A S1b or epsilon A derives A or epsilon, B derives B or B. Okay. Now let us see how to analyze it. What is S1 generating, guys? S1 is generating A power n, B power n, isn't it? And what is A generating? A is generating A star. And what is A is generating? A is generating A star. What is B generating? B is generating B plus. B is generating B plus, right? Now what is AS1? AS1 is A star followed by A power n, B power n, right? Union. What is S1B? S1B is A power n, B power n followed by B plus, right? So what can I write this one as? I can write it as A power m, B power n such that m is greater than or equal to n. A power m, B power n such that m is greater than or equal to n, union A power n, B power n such that n is less than m, right? So m is greater than or equal to n and n is less than m, which means it is covering everything. All these strings will be covered of the form A star B star. Therefore, A star B star is the language accepted by this grammar. A star B star is the language generated by this grammar. A star B star is the language generated by this grammar. Let's do few more examples. A power m, B power n such that m is greater than or equal to 2n. A power m, B power n such that m is greater than or equal to 2n. Okay. So m has to be greater than or equal to 2n, which means A power 2n, B power n, and then it has to be greater, which means A star. Okay. If you write like this, then A power m, B power n such that m is greater than or equal to 2n will be satisfied. Right? First you generate this. A derives A, B or epsilon. Imagine n comma n greater than or equal to 0. ठीक है. And then you generate A star. B derives A, B or epsilon. B derives A, B or epsilon. ठीक है. B derives A, B or epsilon. Now S derives A star, which is B followed by A power 2n, B power 2n, A power 2n, B power n. S derives BA. ठीक है. Got it. Now we will see one more question. Okay. Let's see an interesting example. A power m, B power n such that m is greater than or equal to 2n plus 3. m is greater than or equal to 2n plus 3. ठीक है. तो A power 2n plus 3, B power n. You can write it like this, and then you can put a star in the beginning. Now what will happen? M will be greater than or equal to 2n plus 3, right? So m will be greater than or equal to 2n plus 3, right? Now you can generate this. First you can generate this. What is this? A power 2n, A power 3, B power n, and then A star. First you generate this. A derives A, AB or A. Now what is A star? B derives AB or epsilon. Now what is S? S is B followed by A. 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 Okay? We will see more problems.